So today in algebra, we practice calculating all the things that we learned how to calculate by hand, just now with the graphing calculator and Desmos. I mean, I didn't show you with your graphing calculator because there's tons of graphing calculators out there. So you really just have to look up your model calculator and whatever you're trying to do with it, like into Google. So I can show you, for example. I do have some graphing calculators in the room, but it's only for in case of emergencies. So like when the Wi-Fi goes out, then you can't really use Desmos on your quiz or test. Then like this is the only time I pull them out. I only have like 10, so like they share. And I've only ever had to do that once. But I don't let you use them if you don't bring a graphing calculator for any other time, because that's not how it works like on testing day for your state testing or when you take your ACT/SAT. You have to bring it or you don't get to use it. And they say that all the problems can be done without a calculator, but when there's like so much scholarship money attached to it and grade bumps and things like that, like you probably should use a calculator. So like this one, graphing calculator, it's a Casio. The model numbers in the top right corner. So yours will also have the model number there too. When I go and try to figure out how to do all the things that you saw in Desmos, this is what I would do. I would open up Google. It's a Casio FX, and you can already see like it pops up because probably tons of other people have looked up that before, and say I want to find the standard deviation. I type that in, and then look, a video pops up. There's videos for pretty much anything you could do with the calculator, and this person will walk you through it like step by step. And it even gets to the point, like it gets to right where they're actually showing you with the calculator. So that's what you will have to do with whatever calculator you buy or use or check out. And what gets pulled up, and I know it's blurry right now. Let me see if it gets better when I play it. All right, it shows you how to enter all the data. So that's what you would do first, and it'll walk you through that when you do it on your own. And then later it'll show you all the statistics that get pulled up when you hit enter. So some of these symbols you might recognize, some of them probably not. But in the video, it tells you like that the one he's pointing at is for your standard deviation. And then up here is your mean. Whatever you're trying to figure out to do, there's a video out there that already can show you how to do it. Okay, so that's what you'll do for your graphing calculator. I just show you off Desmos because that'll at least get you through all your unit tests and quizzes, because you should always have a Chromebook every day, no matter your financial status. So questions on that? Do we still need some help calculating mean, median, IQR, standard deviation, or MAD with a graphing calculator? We could talk about that too. All right, if we do, don't be shy. Here's like our to-do list for the day. So your practice for lesson 6 was the backside of your note sheet. So I will check that in Math Lab for you guys right now. You still need to save it for your binder check, but I want you to make sure that that's done. The answers are right here. So check as you go, make sure that they are right. And that'll be some of your points for the day in Math Lab, is making sure that that's done. So have it out on your desk in the corner if it is already, or get it done first. Then you will do any other things that you're missing from the week in Math Lab or from algebra. And another option, once you're done with the first 2 things, is to retake or test correct that quiz from algebra. All of them. Like the second half of class, we'll do a Kahoot to practice like all the other stuff from algebra today. And then I have my TAs grading the box plot proposal. You'll get that back as soon as it's graded for what you have. I know some people weren't finished, but you can finish it and resubmit it. But I just need to take down what you have so far. So that will be coming soon. Questions on anything? Okay, so then there's that to-do list. We'll check in like halfway through class. All right. What does the acronym MAD stand for? Maximum average deviation, mean average deviation, minimum average deviation, or median average deviation? Okay, great. Technically in class, we said it was mean absolute deviation, which it is. But out of these four options, the only one that it could be is the one that's a mean. For us, right? Again, you don't have to write like the whole thing, just put like MAD equals mean average deviation or mean absolute deviation. Okay, so the next one. You have calculated the math for the top four scorers on the team. Who is the least consistent? Those are all the math. Who's the least consistent? So again, another fast one. Now we've talked about what MAD, IQR, standard deviation, what those all measure. So would that be center or spread? Spread. So that's something that I would write down. MAD is a way to quantify how spread out the data is. So the higher the MAD, would you say that that's more or less spread out? So then that would be more spread out. So then the lower the MAD would be less spread out. So then when we're talking about like consistency, we all know that these are the top scorers, so we all know that they're good. But who would be the least consistent? It would be whoever has the higher MAD. So that means his scores are more spread apart, so that's why it was Jerome, and they're more spread out. Versus who would be the most consistent? Jimmy, whose MAD is the smallest, so it's the least spread for Jimmy. So questions on that? All right, put that on to the next one. All right, this one says, what is the problem with using range as a measure of variability? All right, so variability is another word for spread, just FYI, we'll use both in here. Now what's the formula for just like normal range? So what you just mentioned is interquartile range. But what about just normal range? Similar to IQR, but it's not just the quartiles. Yes. Good, so normal range is maximum minus your minimum. And that's why it's not exactly the best measure of variability all the time, because say we have this data. Question? Yes. Say that this is our data and it's like test scores of a person. Say it's like 43, 72, 73, 75, 78, and maybe 100. So what would you say that most of his scores are around? That's my data. That's supposed to be his test scores. What does he usually score? Around the 70s. But if I just took the range of the entire thing, 100 minus 43, then that's saying that his scores are spread out by like 57 on average. Are they really though? No, just because he did really bad on one quiz, but like 100% on another, that doesn't best represent it. So when something's really far from the rest of the data, those are outliers. So range is susceptible to outliers, which is why it's not like the best measurement. IQR would be the best measurement because, and let's do the IQR real quick for this. My middle number would be between these two, which means that my Q1 is 72, my Q3 is 78. So when we do that math, we get 6 for the IQR. And doesn't that like better measure like how spread out the data is in reality? Right, it should. Because more of his data is closer together, it just leads to really different numbers that make it not look that way. Okay, questions on that? All right, so that's why we usually don't use range all the time. What is a good reason to consider using the IQR as a measure of variability? It's not subject to outliers. It ignores 50% of the data. It's quick and easy to calculate. IQR is Q3 minus Q1. Okay, so all of the answer options are true. Yellow's more of an opinion, but the red one is the only good reason out of all of them. So the IQR is not subject to outliers, so it's only looking at the middle part of our data, the middle 50% of our data. So yeah, it does technically ignore the other 50%, but that's not why it's a good reason. It is Q3 minus Q1, but the best reason is because it's not subject to outliers. All right, so the next one. Calculate the standard deviation for the data set. And the only way that you would know, unless you remember it from a prior year, which I doubt it, is with that graphing calculator. And you have about 2 minutes to do it, so you have enough time. The data set is 10, 12, 18, 20, and 30. All the calculations, standard deviation is the only one that we just absolutely did not bother trying to learn by hand this year. I have had students do it by hand in the past, and it would literally take like, I don't know, 30 minutes for one problem. Not lying to you, it's a long process. What you do need to know about standard deviation is if it measures center or spread. So what does it measure? Center or spread? Spread. So the higher the standard deviation, so it's similar to the math. The higher the standard deviation, is it more or less spread out? More spread out. And then, again, if it's lower, then it's less spread out. If it's 0, then we're saying that it's the same data value for the entire data set. So I'm glad no one picked blue this hour, because obviously this is not the same number repeated multiple times. Now some of these you can also eliminate because, like, for example, 62. That would be implying that on average, this data differs by like 62. Would you say that? Like the difference between 10 and 12 is that like anywhere near 62 or any of the other numbers? So definitely don't want to pick the red one then, because that's just way too big. These two, and even just looking from those, it doesn't look like on average they're spread out by 15. If you were just guessing, this one would be a good guess. But you can actually get a number, and I'll show you that. And you do need to know how to use the graphing calculator. So Desmos is the standard one that you'll be using, unless you get your own, which you should. I would put like D for data. The numbers were 10, 12, 18, 20, and 30. So I had 5 data points. I should have 5 in my list. You have to put the brackets or it doesn't do anything. And then if I want the standard deviation, that might be easier to find with the functions button. Scroll down to statistics. That's the unit that we're on. And I usually just find both because there's normal standard deviation and then standard deviation of the population. I never know which one to use unless there's like more words in it. But as you can see, aren't these two values pretty similar? They are. And then one of them matches one of the answer options, and that's the yellow one. Does that make sense? Okay, so there you go. You could have done it with a graphing calculator. On to the next one. Which of these schools' GPA would have a smaller standard deviation? School A is on top. You only get 13 seconds. Sorry, you don't get to use the graphing calculator this time. Okay, so you could have, like, if you had more time, obviously you didn't. You could have put all of these, like for each dot plot, into the Desmos and compared the two values that you get. However, the reason why you didn't get more time, and this is also something that's coming up in algebra, is because since you know that standard deviation measures what about data? Close. What does range measure about my data? And standard deviation. And IQR and math. What does it tell me about my data? How spread out it is. So if you want to know which one has a lesser standard deviation than you would detect, just look at how spread out it is. Would you say that A is less spread out or more spread out than B? So let's see. A, both of the number lines start and end at the same numbers, but for A, all of their data goes from 2 to 4. Where school B, their data goes from 0 to 4. So which one is less spread out? A or B? So we would expect A to have a smaller standard deviation, does that make sense? So if you have the visuals, you don't necessarily have to do the math each time or the graphing calculations each time. Since we can see that this one's less spread out, school A has a smaller standard deviation. That makes sense? We haven't really talked about that in algebra yet, but it's coming. So just now you know. All right, next one. Outside of a sports, I don't like this one. I'm going to skip it. I remember it. Sorry. There's like a few that I didn't like. They were just weird. I'm going to skip this one too. Skipping it. Hold on. Hopefully this one's good. I don't think I've seen this one yet. Calculate the MAD of the data set. So there's your data set. 15, 21, 22, 27, and 30. We're looking for the MAD. For the MAD, we did teach you how to do it by hand. However, do you have to now all the time? Or can you use a graphing calculator? You can use a graphing calculator. Earlier someone said, oh yeah, I just Googled it. Like I Googled a mean absolute deviation calendar, or not calendar, calculator. Okay, great. You can't use that on your test. But like the Desmos calculator is basically the same thing. Like you just type in your data. You just have to know to put the equals and the brackets and 15, 21, 22, 27, 30. All right, and then you can literally just type in MAD because it recognizes that as a function, put parentheses, whatever you called your data set, and it is 4.4. You could also find it in this functions menu under statistics right there. Well, probably not in the same cell, but you get the point, I think. So that'll be our last one. We're gonna pack up a little early.